Hi everyone. Today we are going to be talking about number sets and how to group different numbers into different categories based on what they look like and different properties. And the way that we're going to do that, or the way we're going to talk about it today, is we're going to go from the most specific set to the least specific set. So the most specific set that we're going to talk about today is the natural numbers. And natural numbers are counting numbers. Counting numbers are whole numbers, they are positive numbers, and they start with one. So like one, two, three, and it would go on and on and on, all the way up to infinity. The next set that we're going to be talking about, or the next least specific set, is the whole numbers. Now, this may sound confusing because we just said that natural numbers are whole numbers, but in this setup, whole numbers are going to be all of the natural numbers, so that includes all of the counting numbers, but it also includes zero. So if you notice, zero wasn't included in the natural numbers, but zero will be included in the whole numbers. So we're going to say 0, 1, 2, 3, and so on and so forth. Okay, so the next set is going to be called integers. And integers include all of the natural numbers, all of the whole numbers, and they include the negative versions of those. So like -3, -2, -1, 0, 1, 2, and 3. And it goes forever and ever in the right direction or in the positive direction, and it goes forever and ever in the left or the negative direction. So they include all positive and negative numbers, whole numbers. Okay, the next set that we're going to be talking about are rational numbers. And rational numbers are not whole, but they're anything that we can put into a fraction. So, for example, like 2/3. 2/3 is a fraction. That is considered rational. Another example, it doesn't necessarily have to be a fraction, but it has to be something that can be made into a fraction. So another example would be like 0.1. Well, 0.1 is a decimal, but I can convert that, or I can change that to 1/10. And because 1/10 is a fraction, that's also considered rational. Even never-ending decimals, like for example, 0.2, like 0.2222, that's the same thing as 2/9. And that's a fraction, so it's considered rational. Now, one thing that I'll suggest is that you can use your calculator to convert the decimal to a fraction by pressing the math button and then press enter twice. And if your calculator can convert it to a fraction, then you know that it's considered rational. Now, if your calculator can't convert it to a fraction, or if you press math, enter, enter, and it keeps it the same decimal, then it is not considered rational. So let's talk about when it's not considered rational. If it's not considered rational, then it's considered irrational. And irrational numbers are just the opposite of rational. So they're any number that I cannot put into a fraction. So any never-ending decimal that doesn't convert to a fraction, any of those weird numbers like pi is a never-ending decimal, or another example would be anything with a square root that can't be simplified. So like for example, the square root of 2. If I plug in the square root of 2 into my calculator, it won't simplify. It's not going to convert to a fraction. And so that would be considered irrational. Okay, and then the very last number set that we're going to talk about is the real set. So the real set is really any number that we talk about. There's something called the imaginary set or the unreal set. We're not going to talk about it in this video, or we're not going to talk about imaginary numbers in this video. So the all of these numbers are included in real numbers. Like the real set is the least specific. So all of the numbers that we've talked about so far are considered real, even the irrational ones. So I'm going to say, like, let's say any number in other sets. Okay, so now that we've gone over all of the sets, let's talk about some examples. Let's see, so number 1, let's say negative 12. So the goal here is to decide what sets negative 12 belongs to. So the easiest way for me to do that is to go from the least or the most specific and kind of work my way down. So let's talk about the natural numbers because that's the most specific. Negative 12 isn't a natural number because it's negative. It's not positive. It's not, well, just because it's not positive, it's not considered natural. It's also not considered whole because it's not 0. But integers have negative numbers. So negative 12 is a negative number and it's a whole number, which means that we know automatically that negative 12 has to be an integer. Now, because we know it's an integer, then we also know it's rational. And the reason why we know it's rational, so here's the deal. We talked about rational numbers being any number that we can convert to a fraction, right? Well, negative 12, I can change to a fraction. I could potentially say negative 12 is the same thing as negative 12 over 1, right? So any integer is also rational. And it kind of goes down that way. So like any natural number, or let's say any whole number is also natural. Any integer is also whole. Any rational number is also an integer. The only one that does not get included in this is this irrational. But like we talked about, the reals are encompassing, like all encompassing for everything. So back to this example, we know it's integer. We know negative 12 is an integer. We know negative 12 is rational because it's an integer, which also means that we know that it's real. So these are the 3 number sets that negative 12 belongs to. Now let's go through another example. So number 2, and let's do 18 over 4. So when you have a fraction, the first thing to do is see what you can do to simplify it. Both of these numbers are divisible by 2, so I'm going to divide both of them by 2, and I get 9 over 2. 9 over 2 is the simplest this fraction will go. So now let's go from the most specific set to the least specific and see where we land. So natural, it's not natural because it's not a whole number. Whole, it's not a whole number. Once again, integer, it's not a whole number. It's not negative, so it can't be an integer. And rational, so rational, the rational set, if you remember, is anything that can be converted to a fraction. Well, 9 over 2 is a fraction, which means that we know for sure that it's rational. And because it's rational, we also know that it's considered real because everything in here is real. And these are my 2 sets that it belongs to. All right, we just have 2 more examples to go over. So number 3 is the square root of 34. Now, later we're going to learn how to simplify square roots, but for right now, the way that I want you to try and simplify this is to just plug it into your calculator. So plug in the square root of 34 into your calculator. It's going to give you, let me plug it into my calculator. So when I plug in the square root of 34 into my calculator, I end up with something like 5.83095, and it just keeps on going. So the next step would be to say, okay, this looks like a never-ending decimal, but let's just make sure that it doesn't convert to a fraction. So then you press math, enter on your calculator. When you do that in your calculator, it's not going to change it to a fraction, which means it really is a never-ending decimal. Because it's that never-ending decimal, we can skip through this first chunk of different number sets and we can go straight to the irrational because irrational is those never-ending decimals. So I know for sure this starts as an irrational number. And because it's irrational, we also know it's real because everything in here is going to be real. But those are the only 2 sets that it belongs to. Okay, and then let's go through this last example. Let's see, number 4. And this one is the square root of 25. So, once again, square root, let's plug it into a calculator. When you plug the square root of 25 into the calculator, you're going to end up with just 5. So that's a whole number. That's as simple as it'll go. You could try and turn it into a fraction by doing the math, enter, but it's just going to give you 5 again. We could potentially say that it's like 5 over 1 to make it a fraction, but we're gonna just go with this number 5. So I'm gonna scroll up a little bit just so we can see all the different sets. So we've got natural is the most specific natural number, if you remember, is a counting number. Well, 5 is a counting number. 5 is something that like when I count my fingers, I can count to 5. So that means that this is natural. And because it's natural, I also know that it's whole. And because it's whole, I also know it's an integer. And because it's an integer, I also know it's rational. Because it's rational, I also know it's real. And those are all of the sets that the number 5 belongs to. I hope you can see that there's just not one set that many of these numbers belong to. They belong to several different sets, or they can be categorized in several different ways. And good luck.